Welcome to this VLSI Design lecture series. In today's lecture video, I'll be discussing about dynamic random access memory, DRAM. So we already are familiar with the semiconductor memory classification. Semiconductor memories are majorly classified under two major classifications: read-only memory, random access memory. Read-only memory is non-volatile in nature. Random access memory is volatile in nature. ROM is again subdivided into masked programmable ROM, programmable ROM, erasable programmable ROM, electrically erasable programmable ROM. RAM is subdivided into two variations: static RAM and dynamic RAM. The area of interest in today's video lecture is dynamic RAM, dynamic random access memory. So we'll see how read and write operation is performed in this DRAM. DRAM was invented by Robert Dennard in 1966 at IBM, and it works much differently than any other types of memory units. The fundamental storage cell within DRAM is composed of two elements, a MOSFET and a capacitor. When a bit needs to be put into the memory, or when a bit needs to be written into the memory, the transistor or the MOSFET which is used to discharge or charge the capacitor. A charged capacitor represents a logic level high, which is 1, while a discharged capacitor represents logic level low, which is 0. So depending upon the bit line, whether it is logic level high or logic level 0, the capacitor will either be charged or discharged. If the capacitor is charged to a definite value, the logic level of that capacitor is high. If the capacitor is not stored with any amount of value, or the capacitor has no charge in it, its logic level is 0. So majorly DRAM is composed of an N-channel MOSFET and a capacitor, a MOSFET and a capacitor. So depending upon whether the MOSFET is on or off, the state of the capacitor is defined. Whether the capacitor is storing the data or it is not storing the data, or whether the capacitor is charged or discharged, it will be decided by this MOSFET. The charging or discharging is done via a word line and bit line. This word line and bit line is very essential for charging as well as discharging of the capacitor. So this operation of this DRAM can be understood easily with the help of circuit diagrams. Let us first consider how the data is written in dynamic random access memory. For that, let me consider this circuit diagram. Here, if we observe, we have used same two circuit elements which I have mentioned previously, a MOSFET and a transistor. Sorry, a MOSFET and a capacitor. This MOSFET is N-channel MOSFET, which has three terminals: gate terminal, source terminal, and the drain terminal. Gate terminal of this N-channel MOSFET is connected to word line. Source terminal of this N-channel MOSFET is connected to bit line. Drain terminal of this N-channel MOSFET is connected to capacitor. So depending upon the word line and bit line, the capacitor will either be charged or discharged. Let us consider bit line is equal to 1. The data which is present in the bit line is equal to 1. And similarly, let us consider the word line is equal to 1. So when word line is equal to 1, because the word line is connected to gate terminal of this N-channel MOSFET, as we already know, when NMOS is supplied with gate input of logic level high, NMOS transistor is on. And when NMOS transistor is on, there is a definite connection established between the source terminal and the drain terminal of the MOSFET. That means it acts as a closed switch. When NMOS transistor is on, it acts as a closed switch. If it acts as a closed switch, The data which is present here from the bit line will be transferred through the source of this N-channel MOSFET. Through drain, it reaches the capacitor. And because the bit line is supplied with data called as high value will be stored in the capacitor. That means 1 bit will be stored in the capacitor. Capacitor gets charged. So this is how high input is stored into the capacitor. Similarly, the same thing has been represented here. Bit line 1 is transferred and 1 bit is stored in the capacitor. Similarly, let us consider how logic level 0 is transferred. Let us consider the word line is 1 and bit line is 0, logic level 0. So when word line is 1, it is connected, this word line is connected to the gate terminal of this NMOS transistor. And because the gate terminal of NMOS transistor is connected to logic level high, this NMOS transistor is on. And when NMOS transistor is on, there's a connection established between the source terminal of the NMOS and the drain terminal. It acts as a closed switch. So whatever data is present from the source, it will be transferred to the drain terminal. So because the input which is present in the source terminal, it is connected to bit line called as 0, the same 0 will be transferred to the capacitor. So 0 bit is stored in the capacitor. So this is how the data is written. Similarly, the data can be read, exact opposite of that. During a read or write, the word line goes high and the transistor or the MOSFET connects to the capacitor to the bit line. Whatever value is on the bit line, whether it may be logic level high or logic level 0, it gets stored or it gets retrieved from the capacitor. If it is stored in the capacitor, it is called as a write operation. If it is retrieved from the capacitor, it is called as read operation. The charge which is stored on the capacitor is very, very feeble, very, very small to be read directly. And hence, we will be using a separate circuit called as sense amplifier circuit in order to detect small changes of charges. The sense amplifier detects the minute difference in the charge and outputs the corresponding logic level. The act of reading from the bit line forces the charge to flow out of the capacitor. So this is how read as well as write operation is performed in dynamic random access memory. I hope that you have understood this video lecture. Thank you.